Hello and welcome to Maths at Derby tutorials. I'm Natalie and I have with me this week Neo.
Hello.
And Neo is a first year maths student as well, again in the same class as myself. And Neo said to me he'd quite like to chat about prime numbers. Is that right?
Yes, I mean, as a mathematician, prime numbers are some of my favourite numbers. This is one area of maths that I'm particularly interested in, and I'm happy to answer any kind of question you want to talk to about prime numbers because I've got lots of facts and information about it.
Fantastic. Well, let's see what we can come up with in that case. Well, knowing that you were going to talk about prime numbers, I went through the Twitter that we've got at Derby Maths Society, or Derby Maths Soc is the Twitter account, and on there we follow great women of mathematics, and we also follow the Count von Count from Sesame Street. So I looked up, and what the Count von Count does is that, and there it is. So the Count von Count, he tweets a number every single day, so they become kind of sequential. And then the Great Women of Maths Twitter account, which we also follow, and they've written a blog for us as well, actually, so you should look it up on the website. Every time that Count von Count tweets a prime number, they get really, really excited about it. So I thought probably the first and best question to ask is, what is a prime number?
Yeah, I mean, we as mathematicians, we like to define things first, don't we, Natalie? We know a lot about that when it comes to some of our maths lectures and lessons.
Well, I love the fact that we're calling ourselves mathematicians in first year maths, so I'm really enjoying that. Yeah.
Sure, I mean, you know, we study maths, so I would say we are mathematicians. Yeah, we're gaining our knowledge.
Fantastic.
So yeah, to define a prime number, most commonly it's any whole number, such as 1, 2, 3, 4, 5. Those are whole numbers. Any whole number that can only be divided by 1 and itself. So an example of a prime number would be like 7, for example.
Okay.
So 7 has only 2 positive integer divisors, 1 and 7, also known as natural numbers, as we kind of know as mathematicians. So yeah, essentially when we have prime numbers, these are sometimes referred to as strong numbers, numbers that can only be divided by themselves and the number 1.
So this is a prime number because it can only be divided, and it seems quite incredible, doesn't it? It can only be divided by 1 and 2,683. There's
Correct,
nothing
yes.
else that can
No.
divide into that.
We can't half this number, we can't divide it by 3, no other numbers. Therefore, this is a very strong number. This is a number that can't be broken down.
So that's another point. So anything that can be divided by 2 is obviously not a prime number, and so that means
there is one exception, of course, but the number 2,
the number
it's
yeah.
like a little bit, but yeah, exactly, which is why 2 is strange.
So any even number basically that you get, is not a prime number.
Correct.
So I mean, I would have thought as numbers go on and mathematicians have tested prime numbers, it gets more and more difficult to to understand a prime number or to find a prime number.
Sure, yeah, exactly. Would you like me to talk a little bit about it? I have a bit of knowledge on that.
Oh yeah,
No,
take
sure.
it away.
So yeah, what's nice is there are like groups of people, mathematicians who have like lists of prime numbers up to like 1 billion. So you know you can go very easily find like the first billion prime numbers or prime numbers up to 1 billion. And the difference between prime numbers is never usually kind of more than 100. So a nice example would be kind of the difference between 2 and 3. That's only 1, so they're right next to each other. Then prime numbers are sequential. But even when you get up to like a prime number that's above 1 billion, the next one after that is like no more than kind of like, 50 in terms. So you know, you might have one number and then there's like 50 numbers and then the next number. But that's kind of like a little bit strange when you've got these really large prime numbers, but the difference between them is still really small. So prime numbers are always relatively close to each other.
Okay, so there's no kind of like mathematical formula that will just tell you what a prime number is?
Unfortunately not one specific, but there are many other ways to kind of like prove
some techniques that people have come up with. And then what's, can you say opposite? What's a number that isn't a prime number? What's that called?
That's quite funny because some people might like to say an anti-prime, but myself included, I don't think this is appropriate because they're actually composite numbers. These are numbers that are literally the mathematical opposite of a prime number. These are numbers that can have, these are numbers that have the most divisors. So whereas prime numbers only have 2 divisors, 1 and the number itself, these composite numbers are numbers that can be divided by the most amount of numbers. And I do have one example. So the number 5040 is a lovely number. It's a lovely composite. It's a highly composite number. 60 divisors.
Okay.
So 60 different numbers can divide into it, including all of between numbers 1 and 10. All of those numbers can be divided.
Oh, so I suppose like then that's a perfect number for Nick, our statistics lecturer, if he wanted to run a maths quiz and he wanted sort of perfect sets of numbers of teams. That would be the ideal number. One of the ideal numbers of students to have would be 5040. That's
exactly, yeah, because you could split that number up into 5 groups, 6 groups, 7 groups. You can divide it through by lots of numbers and make lots of nice, neat groups that you might want to like use for certain things.
Yeah, and you sound like really passionate about kind of prime numbers.
Yeah.
Why do you like prime numbers so much?
I kind of like that mathematics is almost called, almost like said, well, they are strong numbers. These are strong numbers. So if we just speak a little bit about the fundamental theorem of arithmetic, which states that all numbers, so all natural numbers, so 1, 2, 3, 4, and then sequentially they move as a whole numbers, I suppose you could call them, that are not prime numbers.
Well, the natural numbers, yeah.
Yeah, exactly, as they're actually defined, natural numbers that are not prime numbers. All of them are the product of a unique set of prime numbers.
Oh, okay, so that's quite a magical property in itself.
Yeah.
Yeah, okay, fantastic. Well, yeah, there you have it, prime numbers. So on that tweet that we have, oh, we can't,
oh, yeah.
Oh, yeah, no, there it is again.
There it is again.
2,683 is a prime number. I was looking this number up as well in the just this morning, and I discovered that not only is this a prime number, but it's actually the name of a galaxy.
Wow.
So it's NGC 2863. It's the name of a spiral galaxy, which is one of those typical galaxies that you see in sci-fi movies as well. So it's really awesome. And I also learned that the person who discovered it, Herschel, if I say his name correctly, a replica of his telescope has actually been built in this university. So
that's brilliant. I hadn't even heard about that. There we go.
That's right. I only just discovered that. So I thought that's probably one of the things we'll do after this is go and see if we can find that telescope in the university.
We'll have to scour the corridors and be like, right, let's have a look then.
And we've also got Nick's maths quiz to go to now as well. So that's why I probably look a bit tired because I'm quite nervous about that. So
it's going to be good. It's going to be good.
Fantastic. Okay. Well, thank you very much, Neo.
No problem.
And thank you very much again from Maths at Derby.